Okay, folks, we'll get started. So welcome. Thank you for joining us today on this webinar on how to build real device testing labs that pay for themselves. So with myself, Nicholas Metcalfe, I'm head of technical sales at Cambrionix, and joining me today is Farid, formerly from Snap. So we'll do some introductions in a minute, but first of all, we'll just do some housekeeping information. So everyone's mics are muted, so you won't be able to speak during the webinar, but there is a Q&A panel. So if you do have any questions or anything you'd like to ask as we're going along, please feel free to pop any questions in there and we'll come to those. All the slides and information regarding this webinar itself will be forwarded over to you. So there'll be a follow-up email after this that'll be sent across with all the resources and things you need. The session today should be around 50 minutes. So we do have a demo recorded earlier on today showing the product itself and it processing multiple devices. We are recording this webinar. I do know that lots of people can't make it. We've had a few people that have reached out and said they want it recorded to be able to view it at a later date. Similarly, if you do have any colleagues or anyone else you think this would be interesting for them to watch it as well, please feel free to share the recording once that goes live as well. If there are any issues, please do reach out, drop a message, let us know if you can't see anything or hear anything. We'll look to help that as well for you. And then if you don't want to ask questions during the webinar itself, do jump in at the end. We do have a Q&A session for anyone to ask any questions. So this is just a quick agenda of what we're looking to. So we'll just do a quick introduction of who we both are. We'll talk through the problem being seen today with regards to testing and the cycle of software development. We'll be talking about real device testing and why that is so important to be able to do and to be able, it's really important for your development cycle. Farid will speak a little bit about Snap and their story and their journey through device testing. We'll do a little bit of talk about ThunderSync 5 and Cambrionix and what we can do to aid anyone with regards to this testing. We do have the demo that recorded earlier on today, and then we'll do a little Q&A at the end. So we start off, Nicholas Metcalfe. Nick, been working at Cambrionix for just over 6 years now. So head of technical sales engineering, manage a team, a global team with regard, and what we do is we help any customers sort of consultation-wise if they need help setting things up, writing scripts, if they're looking for any inefficiencies in their workflows and the way they do things in their operations. The company itself, we work in many different areas, SQA being one of the biggest. So, you know, real big companies that do lots and lots of software and hardware testing. So we aid them a lot, helping them with sort of scripting, API, best hardware setups, all that kind of stuff. That's myself. And Farid, if you'd like to introduce yourself.
Hi, yes, my name is Farid Shayegh. I am an engineering program manager. I've worked at Snap for almost 9 years, helped them build out a data center mobile testing farm. I am all very familiar with Cambrionix and everything that they have to offer. We worked very closely with Nicholas and team over the years, and very excited about this.
Excellent, thank you very much. So we'll look at start off a bit of sort of a moment of what's happening right now. So the industry moment is what we're talking about, and one of the biggest things that we're seeing, both internally and externally, is the use of AI to enable software teams to develop faster, to generate more features, faster, to be able to produce them and enrich their product. So this is Andy Jones, this is the CEO of Cambrionix, and he's really looking at what AI is doing. So there's such a long list of features that people want to add to their products. People want to really bulk out and add these features and improve what they are providing to their customers. And AI is a great tool. It's come along and it's really, really sped up what people can produce and what they can do within their companies. The thing with this is the faster you develop code, the faster you push features, you still want them to be reliable. You still need to test them. And that's something that's super, super important to all customers. So if we're looking at what AI is doing, as I said, we're using this internally. When there's new features or there's something that we'd like to produce ourselves, we're using these AI tools. We know lots and lots of customers are doing the exact same thing. AI adoption within engineering for both hardware and software is super, super accelerating everything that's happening. With all of these features, with all of these great new things people are developing, the testing still needs to take place. And it's becoming more and more of a problem, more and more of a bottleneck for developers to be able to, do their PRs, checking exactly what's being done within the code. Is it going to work? Are we going to introduce a breaking problem within the software stack in itself? So if you're looking to do all these tests and you're significantly increasing the output of a team, how are you going to match your infrastructure and how are you going to perform these tests to enable that really solid product at the end of it? So if we go back a little bit, in order to push additional features, in order to improve your product, you would need to hire more devs. You'd have to employ a lot more people to be able to, first of all, write the new codes, write the improvements into your software stack, and you'd also need to hire additional software devs to test this. You could automate this. You could script a lot of the testing themselves to run, but you would always need someone dedicated there to be able to watch what was happening. If there was a failure, they'd have to go into the logs. They'd have to look at exactly what was the root cause of this failure in itself. What's happening now is the tests themselves have become the bottleneck with this AI introduction of the devs. So you don't need to hire more software devs to be able to do the writing of the additional features. Your current devs that you have are able to do that. The testing part has become the bottleneck because the devices can only run so fast with your infrastructure. You need to be able to test them, and you need to be able to test them at scale very, very fast. The lab that you have and the lab that you're using to be able to do these tests is now the most important thing. You can only have so much real estate. You can only have so many devices in the lab. Land is expensive. You can't just increase the size. So what do you do instead? You improve the efficiency of the devices and the information you have available to yourself. So would be why real device testing is super important. So you can simulate, you can emulate testing. So there's lots and lots of applications and facilities out there that will allow you to do simulation and emulation of devices to run your tests. This is great. This is a super, super fast way to be able to validate that the code that you're pushing is correct, that it works. You can put it onto these devices and the application will run as you expect. This is a great first pass. In no way am I saying this is not a good thing. I think it is a great thing. I've used emulators quite a lot in the past to be able to look at how certain features will work, and it is great. It does a really good job for you. But with a simulator, that will never 100% reflect what happens in the real world. A simulator is not going to tell you about a specific iPhone that you have that's been sat down for 10 years and then they launch an application onto it. It's not going to tell you about something that's been out in the desert or somewhere really hot or somewhere really cold that's really been used quite hard. That also has to load the application, and the user experience you want to be the same. You want it to be good, you want it to work for them, and you just want to load it up and they're happy. Any slight glitches or problems or any degradation in the device itself or the battery or the memory, that will essentially mean that the application or the software that you're pushing won't be as reliable, and then it will look at to people that they won't have as much trust in that software. So yes, emulator is great for being able to do that initial validation, but you also need to have a real device that's being run to validate that, yes, okay, it works in theory and it works in practicality too. So this is what most people are doing. So you're using that virtual layer, you're using those emulators and simulators, pretty cheap. You can run this, you can run all your tests against it. You can see that it's going to work for you. The application itself isn't breaking, all that's good. Once you've done that initial push, the next section would then be real devices. You have all different types of phones, tablets, computers, whatever it is that you're loading your application on. You need to have all these different variants and different products that need to be tested against in real world conditions. So this is what we've seen with lots of different companies we work with. So, you know, your Googles, your Apples, your Metas, and your Snaps, they all do this. You know, you do those emulated tests. Once you've emulated that it works in theory, you then want to make sure that it works practically for them. So this is, some people don't do that. Some people just skip straight past the real devices. And what can happen? You push this application out, it doesn't work. There are problems. People lose faith in your application. They lose faith in your software. They don't want to use it. You know, support bugs go up. Your team start to get inundated with questions about, you know, what's wrong with this? Why isn't this working? And you generate a lot of bad noise about what you're doing. So doing these real device validation tests are super, super important to show that you know what you're doing, your software's working as it's supposed to. People have faith in what you're doing. Your brand has credibility. People are happy on that. And you yourselves know that the product that you're shipping out to your customers is the best it can be, and you can trust it and you can stand behind it. So that's a little bit about what we're seeing and how people are testing and, you know, emulation and real devices. And what I'd like to do now is for Farid to jump in and sort of speak a little bit about what you've seen and how you've seen this play out from your side.
Yeah, so you know, when I started working at Snap, and one of the reasons they brought me in was that they users being able to get the latest and greatest features and functions, especially with the lenses, to work on the latest and greatest iPhones, which were selling for thousands of dollars. Unfortunately, the typical use case and user on Snapchat was a younger generation, and they were using hand-me-down phones. And as we grew into the rest of the world outside of the United States, it became more Android users. So there was a huge problem with accumulating Android users and keeping them on the app, because the app had all kinds of problems and issues. So solution was to go and find ways to test on these phones from across the world on different OS versions, different memory and SSD sizes, cameras, and processors and GPUs and CPUs and so forth, in order to see if the certain change that is being made on for the app, how would it affect other models that aren't as superior as the latest iPhone, the latest Galaxy device. So I remember walking into an apartment building with a room with a standing cooler that was blowing next to the beach at, you know, about 100-degree weather, with these phones sitting on top of folding tables. And that was the device farm at the time. You know, this goes back to 2017. So my job was to find a way to move this into an area where it can be more feasible for testing. It can run 24 hours a day, and that their on-call does not get paid for temperature going above a certain degree in the middle of the night. So, and I was walking on top of, you know, hundreds and hundreds of patch cords laying on the ground of this room. So first thing I did was, you know, went out there to see what's out there and what are the competitors doing, what's everyone else up to. And at the time, there were no other device farms. You know, you had some people like us who had their phones hooked up to some desks, and the devs were trying to use them. We were writing our own testing software and so forth as well. And then, later we decided that we need to cover pretty much every type of Android device our users are running on, and every iPhone device across any OS versions that are advertised as our app is supposed to work with. So if like we're supporting Android 4 and Android 5, we need to have phones and we need to run our application testing on it daily to make sure those users aren't, having any issues. And I think even till late Q3, 4 of last year, we still had around 500,000 Android 5 users, just to give you an idea of like how, it may be small to others, but it's pretty big when you're talking about almost a billion active users. So we do not want to lose that uh, database. So basically, our goal was, how do we do this at scale? How do we bring in all these devices, put them into a space, and be able to run this 24 hours a day without causing any fires or issues? So one of the things we did was we went out and outsourced and purchased as many devices across all of our DAU that we had, daily active users. And obviously, with Apple, you have certain restrictions. You need to make sure you're using Apple hardware to test on. You can't run them on Hackintosh or Linux. And anything that's Android, you need to see how many devices can you connect to a host. And while we're doing all this, we were trying to do all this with regular, USB hubs that most people, even till today, most major um, competitors and businesses are still doing. One of the issues we ended up having was that we had to hire more and more data center technicians to go out and triage these phones because our system engineers couldn't get through to them uh, unless someone was there with remote hands. And that was getting pretty expensive. On the other hand, whenever we're doing software upgrades and things like that, we needed more people, right? Obviously, by the time I was leaving, we were doing 700,000 daily test executions. And this is a trimmed down version of going through the access and finding developers that were no longer there that had written tests that nobody was looking at, right? Like we're talking about 1.2 million plus per day type of testing that was happening. And we were also running on emulators and simulators and all that as well. But like Nick said, there are things that you cannot do with emulators and simulators, or at least at the time. You know, when you're doing performance testing and you want to do CPU pinning, there were so many different modifications we had to make to the phones themselves in order to accommodate those things. What Cambrionix came into play here for us was allowing us to get to the phone and being able to do so many things that we couldn't do before with regular hubs. Having that API and being able to go in there, reboot phones, get them back online, um, you know, ADB into them and do software upgrades and things like that. I think on cadences, we went from, I don't know, maybe 2,000 phones that needed to have an OS upgrade to be done in about 3 weeks to 3 days. Just being able to do that. And as their hardware, as these Cambrionix units became more and more capable, the throughput really helped out, right? Like in order to be able to actually do as many phones that are connected to these hubs at the same time simultaneously. And I believe Nick has a demo of this later, but that's a testament to what quality these things have. The other thing was that I don't remember having to replace more than a handful over 6 to 7 years. They really worked well. They were well built and they were doing really well for us. So, all in all, my questions would be, how big is your operation? What problems you need to solve? But at the end of the day, a well-built device lab with the right parts in them will blow any outside vendor and any emulator and simulator out of the park because they will not give you everything you need. So yeah, in this case, we'll go to hire it and what works, right? So we figured how many systems engineers we needed, how many on-site. You still need some remote hands to help out at that size. 12,000 phones is a lot. Um, and we were like, okay, how do we take this to our CFO and the CEO and say, we're still worth keeping around with all of these other competitors coming into the field, right? Like now you got Google Fire, you have AWS, and you have Browser Stack. You have all these other companies out there providing these device farms. How do we go show them that what we're asking for in budget year after year is commensurate to what outside services are using, right? So that was the monetary part of it. But then when I was putting that report together, and I did this annually, every year I had to go back and reassure them that we were on the right path. Um, this was such a large farm, and we had so many different types of clients, as we would call them, even though there were different teams within Snap. We had to really narrow it down and really do an apples to apples comparison, right? So I just took our pre-merge, which was our biggest team that really needed to do everything passed through for releases that were happening weekly, right? And we all know that with Apple and Google Play, and more than anything with the App Store, you cannot they will not allow your app to run unless it's passing the weekly release cycle through them. And they are one of the hardest teams to work with in order to get this passed through. They will find every issue, every regression, and they will push back and they will hold back on your release. And you do this one too many times, you will create a bad reputation with them, which then will cause other issues with your app being banned from the App Store. So you have to work meticulously to be able to make sure your tests are well written, very well verified, and that they're actually getting through. So we just took our pre-merge testing and we just said, okay, these are the amount of executions we're doing on monthly basis just for pre-merge. And then forget about all the scheduled runs, performance, lenses, everything else that we had. Excuse me. So then I took those numbers of executions based on the type of devices they were running on and they were utilizing, and I ran estimates across Google Fire, AWS, Browser Stack, and one other. And the numbers were out of this world. So for a single team that was running tests with us, our total cost, this includes phones, hardware, data center costs, lease, power, Cambrionix hubs, even our engineering staff and on-hands help, labor, all that inclusive was somewhere about a couple of $100,000 a month. And this is just one team, right? Ran that across, and companies like Snap get major discounts with AWS and Google, right? And even with them, I think we were somewhere close to $800,000 per month just for the pre-merge testing. And then for Browser Stack and others, we were well over $1 million a month. So a huge cost discrepancy there as far as us running our own data center with mobile farms and being able to really focus on everything that we needed. Our app security team was super happy because everything was shielded from an outside company. They didn't want our app running on other devices that were running other applications from other people, right? And that's a major security risk. So right there in that, security was happy, finance was happy, and our engineers and the developers were happy because they were getting much faster results. So if we could, our goal was to be able to get an end-to-end test completed within 25 minutes. So a developer can actually write their code, submit it, go to lunch, come back, and have their results in their hands. If you try to do that with an outside farm, There's no way you can get that within a day. Hours. It will take hours. And then you're also competing with everyone else that's running their test. How are you assuring that you're going to get the results as fast as you can? And if you're doing that, you're even paying more than others. Now, what building actually looked like? Yeah, it was devastating. You're talking about running all iPhones on Mac hardware. Mac hardware is single source power supply. Eventually, they came out with what we used to call cheese graters, the the Mac Pros, and these were actually able, right? They had rack mount kits, and we could do that. Still no secondary power supply. So in a data center environment, you're dealing with a hardware that you need to run 24/7. That's strictly, if it has a bad power supply, it will go down. There's nothing you can do about it. So we didn't end up using Mac Pros, but at the same time, there was no other Mac that had a secondary power supply or a secondary Ethernet port. So we worked with what we had. The other constraint was that with Apple, you couldn't run more than 3 to 4 phones to a server. So we had these racks full of Mac Minis that were running, less than 120 phones. With Android, however, we had a much better throughput. I think we finally got over 30 phones connected to a single server, and eventually we increased that with the right type of server and Cambrionix latest hubs to close to about 60 phones per server. These were Linux, so we could have dual power supplies and dual NIC ports and things like that. So they made things a lot easier for us to work with. But nonetheless, one of the major issues we had was still running old devices, old OSs, and trying to keep them. I remember one time I would walk by the racks of all these S7 edges that were in those racks, and I just felt this whiff of warm air in front of it. So I went and got one of these laser thermometers, and I pointed at the screen of one of them that was running a test. And I think I had somewhere close to 105 degrees Fahrenheit on the screen while it was running a test. So our biggest concern became battery bloat, right? So what's happening here? The batteries are getting heated, and they're being charged 24 hours a day. They're heating up, they're bulking up. How do we fix this? Because we can't get rid of this device. It's a very popular device still today for our users. So we reached out to Nick and team and said, hey, we have a need in order to be able to extend the battery life on some of these phones, especially for iPhones, because we can't take those batteries out and actually connect them via USB and use them. And there were some Android phones that were like that as well. So one thing that they implemented was the charging and discharging and regulating the charging with their Cambrionix hubs, and that was able to help us increase the battery life and the performance and the bulging of these phones. Remember, so when they're bulging, the screen becomes unusable and the buttons will stop working, and then it's also a fire hazard. So overall, I think partnering up with a company like Cambrionix that actually came through for us, listened to our needs, built software around this that could really help extend the life of these devices, make life easier for our data center technicians, and also our remote engineers, systems engineers that worked tirelessly to keep the system up and running, and still giving our developers a confidence level of saying, these devices, when I do run a test on a mobile device lab at Snap, I feel comfortable knowing that it's our best effort put forward. Whereas when you're looking at outside companies, sometimes you can't even get a hold of someone to talk to, let alone saying, hey, this device, is it my test that I wrote that's having this issue? Or is it because the battery on this device is so bloated that the commands that are going through aren't really clicking where it needs to go and it's causing these problems? And then obviously, with the introduction of simulators and emulators, we were able to reduce our total device test count. But when it came to releases and release tests, there was no way any release manager would be okay with just strictly going through simulators and emulators. Like, it was good if you were doing certain changes to certain parts of your app and you wanted to rerun those over and over again on simulators. And then we would say, and simulators and emulators pass rates were somewhere around 70 to 65%. So it wasn't great, but it was good to do some pre-testing. And then once you came to release, then they would actually schedule it and run a smaller amount on physical devices. If once that passed, they felt more comfortable to actually getting it through to the App Store. If it was not going to pass, then they would bring it back and actually test everything. We would have full results of what the issues were, and they would fix them and put them back through regression testing. I think that pretty much covered that. And yeah, just like I said, like, cost was huge. It was a testament of what we built when every year I would go through the data analysis of cost analysis and also speed and control. The other was how well we were integrating with our CI/CD pipeline. Our CI/CD pipeline was dependent of the test results of these devices on these functional tests. Unit tests will not cover everything. Functional tests are the future of app testing. So in order to do that, you need to have mobile device labs. You need to have well-tested, well-defined test results. And, one of the things I still come across, and I talk to people all the time about this, their biggest problem has always been speed and reliability. And at the end of the day, the results they're getting are accurate, right? And one of the other things that comes once a year at least is OS upgrades. It takes a village to do this, but it doesn't take a village anymore for us, at least, or we did. At the very end, we would have a systems engineer paired with one data center technician, and we would upgrade thousands of phones within days, and without having to cause any issues or having to take any outages, which was huge. Speed is way faster. I'll have you test anything amongst any remote farm and even physical in hand. You'll see how much faster the throughput is. And with the latest Cambrionix hubs that I tested with, they were faster than anything I've ever used before. And cost, like I mentioned before, it's 70% for a well-run device lab is the very least of it. Yes.
Excellent. Thank you very much, Farid. So yeah, that's exactly the sort of thing that we're talking about here, is doing those developments, setting up yourself. You can really see the benefits. So as Farid was talking about, the infrastructure is super important. Looking at Cambrionix hubs, one of the things that we specifically do is we're here to enable people to process devices and run these tests at scale as fast as you possibly can. So one of the things that Farid was alluding to there a little bit is you run a test that it fails. Is it because your code was wrong? Is it because you had some bug within your software itself? Or was it because the hardware and that infrastructure layer had some issue? Talking about battery bloating there, it could be, where you're saying, you can connect a handful of devices. There are a certain amount of devices you can connect. So this is all tied to USB endpoints and how much resource these devices take up when you connect them. This USB infrastructure layer is what can be causing a lot of these problems. A lot of the issues that can be seen are from this layer in itself. So looking at these failures, devices dropping out, this could be because of a reset that you have to do as part of your test, and it can't quite connect afterwards. It could be that you're running a test across multiple devices at the same time, and each one of them is fighting for that bandwidth, using up that USB resource. So one might take 2 seconds longer for that result to come back. That might end up as a failure for you. It could be that you're running resource battery heavy testing. So this could be anything with a torch or a camera or a screen. When you're running these kind of tests, that's going to really drain the battery. And if you're running it multiple times, the phone could just run out of charge mid test, which again could show another failure through no fault of the actual software and the script itself that you're pushing. So as Farid was talking, the latest hub that we have available is the ThunderSync 5C16, and it's from the feedback of people like Farid and other customers that we work with. These are the information and the bits and pieces and the stories they tell us is really what pushes us to produce our products, to improve the hardware and the software layer. So this is using Thunderbolt 5. The idea of using Thunderbolt 5 is it massively increases the throughput to allow each connected device to run fastest speed possible. So you haven't got certain devices fighting each other for that bandwidth. It's available for all of them. It has PD charging. This will allow the devices to charge. If you're running extremely high resource heavy tests, this isn't going to be a cause of failure. 16 devices at once, talking about how many iPhones you can run off of one Mac, how many Android, how many you can run at the same time, severely impacts the output of your team. So maximizing the amount of ports, maximizing the amount of devices will really, really improve your output. As I said, there's a software layer, there's an API, there's a CLI. You can really get down into the granular details about power draw and the USB communication to really drill down and look exactly what's happening whilst you're running these tests, whilst you're doing all of this work with your software. We do have a layer of protection. So this is if you have a bad device, if you have a device that's battery bloated, that back charges, that has any issues, rather than the whole hub going down and you losing that test across all 16 devices, you just shut that one port off. So you still have 15 devices running that test with one turned off as a safety precaution for you to come and look at with an engineer later. So rather than an engineer having to go physically to this location to swap devices out, swap cables out, swap hubs out, you can just pause on that one test and run the other 15, maximizing your output. Here's just some information that we have about the different products. So we ran some tests alongside some competitors. So ThunderSync 5C16, if you're doing a full iOS restore, so it's erasure and update into the latest version, just over 10 minutes across 16 iOS devices at the same time. Compared to the closest competitor, it was twice as fast, 7 times faster than another, and 4 times faster than another one there. So that's real world. If you're having to do a complete wipe of a device in between testing to make sure you've got a clean environment, you're really massively saving time there and pushing these data packets as the IPSWs, as these iOS packages grow and grow and grow, as we're seeing. The amount of time that's being taken on these restores, these updates, this sort of, the cleansing of devices is taking longer and longer and longer. So as I said, I did do some testing earlier on today. So I was in the lab in the office. I had 9 MacBooks and 7 iPads connected up to a TS5 to do a full restore process. So what we have here, the video should begin now. Here, so as I said, I had 7 iPads, 9 MacBooks all connected through to a TS5. What you'll also see in this video is some of the functionality of our software. So on the left there is our Cambrionix Connect software. This allows you to process any devices. So see, the first step I do here is I use our Connect console to put every iOS device into DFU. One click of the button there. All 16 devices will now go into DFU mode. So that's device firmware upgrade mode, which will allow me to push IPSWs, allow me to do these updates. So rather than manually having to do each device at once, you can connect them all up, run that process, again, saving time, saving manual intervention, stopping your engineers from having to do small manual tasks, and allow them to focus on the real things that make your product better and really improve what you're pushing out. So I've sped this up because we don't want to sit here for 10 minutes watching MacBooks update. But you can see here, with what you're seeing on the image, you can see the devices whilst they're doing this update process. They're changing mode, they're resetting themselves, they're doing all manner of different things, but it's stable. You know, if you look at the configurator on the right, the devices are there, they're stable, they're available. So with all these devices, you can see that we're coming to the end of the full restore here. So they've all been erased, they've all been updated to the latest version. 11.5 minutes. There was time there of me clicking around. You could improve that automating it using some scripts there. But you see, there wasn't any problems. We didn't have a point where a device dropped out, it ran out of battery. We didn't have a problem of some data packets disappearing. You know, nothing happened there. I wanted to restore them, I restored them. It's nice and simple. So that speed coupled with the reliability, speed of charging, speed of data, reliable, you plug them in, they're in there. I work with companies that have some of our hubs from 10 years ago. They're still sat there on these server racks, covered in dust. These things are workhorses. They're there to improve the infrastructure. They're there to make sure everything works, you know. And we briefly looked at the software there. So that's Cambrionix Connect. This is our software platform. We have local APIs as well. So I do encourage anyone that's interested to have a look through. We have Swagger documentation, we have user manuals. Reach out to me. More than happy to help. We're looking to help people integrate. As Farid said, we worked together on something. They were seeing some issues. We talked about the APIs. We look through Linux and Mac and Windows, all these different systems to provide an increased value. It's not just a small bit of hardware. There's a software stack as well that's going to improve the team. It's going to improve what you're doing with all of your testing. So some of this stuff, briefly touched on earlier, target charge. If you want to charge a device to a certain percentage and hold it there and just trickle charge, you can do that. Make your devices last longer. We have PD charging. This will allow devices to charge up to 60 watts. Again, heavy, intense testing, things like MacBooks and iPads that need that additional power draw. That's available. Remote management. I can sit here in Cambridge and we've got colleagues all over the US, and I can see their hubs and I can perform actions and I can see diagnostic information. So you can manage it all remotely from one location as well. So that's quite a brief overview there on the software. There's lots of information there. As I said at the beginning, we will pass some information out to all attendees after the event. So I do want to give a bit of time here. If there are any questions from anyone, I do have the QA panel open. I'm aware some people may have ideas, may have questions they want to ask, and they don't have it right now, or it might come to them in 5-10 minutes time, something like that. As I said, more than happy for anyone to reach out via email, ask any questions, look at anything from us there. So I do have a question from Cindy asking if there's any use cases where, I'll ask this to you, Farid, where you'd recommend outsourcing the device testing rather than doing it in-house. Is there certain points that outsourcing is better than doing it yourself?
I mean, the only time I would recommend it is if you're such a small team where you really need to have you don't have the resources to have your own pipelines and being able to create your own tests and certain things where you rely on outside sources. Again, for smaller, very small companies, maybe that would be the case. I mean, obviously, you still want to have a few Cambrionix hubs on your desk for your local testing and QA testing. But other than that, I mean, if you reach out to most of these companies, they're probably using Cambrionix API hub to do their testing. But I spoke to many of them, and most of them didn't have the range of devices and didn't have the latest and greatest, and they didn't have the number of devices that we needed. It was just way out of their ballpark.
Thank you. Yeah, no, I'd echo that as well. I think if you're doing small scale testing, outsourcing, definitely. But if you really want to scale it up, you need to have it yourself. So there's no questions there, and I'm conscious of time. I don't want to keep people later than they need to. So just 3 points on the screen here for you to look at. 3 things that we'd really love for you to take away from this webinar today. Real device testing, super, super important. You can't just rely on emulators and simulators. Doing it yourself, you know, you hear it from Farid. He's been there, he's done that, he's had the journey. Doing it yourself allows you to have that control. And again, the infrastructure layer, the USB layer, the hardware that you're testing on has to be reliable for you. If it's not reliable, you're going to get false negatives, you're going to have problems, and you're going to be looking through your code for where that problem is, and it's not there. The problem is sat on the desk, on the server rack, causing you headaches. So thank you everyone for coming along today. Thank you very much, Farid. It was lovely to chat to you. Said there'll be resources sent around afterwards. If you want to reach out to either us on LinkedIn or via email, all that's available. Apart from that, enjoy the rest of your day or evening, wherever you're watching from in the world, and we'll speak to you soon.
It's been a pleasure. Thank you.
Cheers. Thank you, everyone. Goodbye.